Footage in this video includes installers working on a home with asbestos siding. Before drilling or removing asbestos siding, check with your supervisor. Follow local regulations to ensure worker and public safety. Now let's look more closely at how to drill and probe wall cavities. For this job, the type of insulation to be blown into the walls is cellulose. The minimum hole diameter is 1 inch. For fiberglass, the minimum hole diameter is 2 inches. Start at one corner of the house. Drill the first hole about 8 inches in from the corner and no more than 48 inches up from the floor level. If you hit solid wood, drill another hole a little further in from the corner. Once you get a hole through to the cavity, you can quickly check for any old insulation already in the wall. If you find old insulation, call your supervisor for further instructions. Next, use a tape measure or wire to probe sideways in the test hole to find the next stud. Remember, studs are usually installed 16 inches on center. On this job, after each piece of siding is removed, one crew member drills a hole, finds the next stud, drills another hole, and so on. The other crew member probes every hole for obstacles, then fills the cavity with insulation. If an obstruction is found, additional holes need to be drilled so the entire cavity can be filled with insulation. The crew member who is drilling also keeps a watch on the blowing machine to make sure the bin is full of insulation. If you're using the two-hole method, you're required to drill 2 holes per story for every cavity over 48 inches high. Place the lower hole no higher than 48 inches above the floor. Place the upper hole no lower than 12 inches from the top of the wall. Windows require special attention. For each cavity that the window spans, locate at least 1 hole above and 1 hole below the window. Here you see how stud spacing can be irregular around a window. Notice the 3 closely spaced holes. When you blow insulation into the first cavity at the start of the job, one crew member should stay at the truck to monitor the air pressure setting. The hose operator can then communicate to the machine operator which way to adjust the air for the proper pressure. Too much air might cause weak interior walls to blow out. Blow the low hole in each cavity first. Have the blowing machine operator observe from inside the house while you blow the first few holes. Then, periodically throughout the job, you or your crew partner should go inside to check for problems. If it takes more than 4 minutes to fill a cavity, stop. Check inside the house to make sure insulation isn't escaping from the cavity. On this job, insulation was escaping between the finish wall and the back of the sink. The gap was plugged so insulating could continue. As you blow insulation into the wall, rotate the blowing nozzle from down to up so the entire stud cavity will be filled. You might see insulation blow out of the upper hole, indicating the cavity is filled to that point. Then finish the cavity by blowing through the upper hole until the insulation is packed tight. Here is a demonstration that shows how an empty cavity fills with insulation in a 2-hole blow. Most of the fill occurs from the low hole. Notice how the insulation appears to be packed more tightly at the bottom of the cavity than at the top. That is why you need to use the top hole to finish the job so there is a uniform density throughout the cavity. You'll know the cavity is filled when you see the insulation stop flowing through the hose. If you don't put enough insulation into the cavity, There will be voids and the insulation may settle and not provide the required insulating value. Another insulating technique is called the tube-in-wall or dense pack method. Cellulose is the insulating material usually used with this method. A small diameter 10-foot tube is attached to the blowing hose. This tube replaces the blowing nozzle used in the two-hole method. Only one hole needs to be drilled per cavity unless there are obstacles. Locate the hole where you would normally drill the low hole in the two-hole approach. Push the tube into the cavity until you feel it hit the top plate. Then pull the tube back about a foot. Here is what this procedure looks like in the model. The insulation is then blown into the cavity. You can see how it comes in at the top and falls to the bottom. When it eventually fills to the top, you'll see the flow of insulation in the hose slow. When this happens, pull the tube out a foot or so and blow in more insulation. Continue this process all the way down the cavity. With the model, you can see how the insulation gets more dense as the hose is pulled from the cavity. This approach results in a very dense packed cavity. Whether you use the two-hole or tube-in-wall insulating method, be careful not to miss any cavities. Probe each cavity before you blow. Work with your crew partner if you have questions or need to solve a problem. Establish an orderly work process as you move around the house. On some jobs, you'll need to notify the utility for an inspection before you plug the holes. Once the siding has been patched or replaced, make a final check inside the house. Look under sinks, inside recessed cabinets, and other areas where insulation might have come into the house. Inform the homeowner that the job is finished. Explain what you've done. Give him the certificate of insulation or show him where it is located and thank him for the business. Insulating finished walls requires careful attention to the following procedures. Inspect the exterior walls from inside the house to find potential problems such as recessed cabinets, wiring, and other obstacles. Drill holes at the proper locations. Probe wall cavities for obstructions. Blow insulation to the proper density. Plug and finish the holes carefully. And communicate to the homeowner about the work you've done. Follow these steps and your customers will get a quality wall insulation job.